This is Dr. Holt. This UT problem is on the bullet and is striking a board and traveling at different velocities. We're going to find out the answers to what is the average acceleration of the bullet through the board, how long is the bullet in contact with the board, and what minimum thickness of boards would be needed to stop the bullet, assuming the deceleration through all boards is the same. First thing I would recommend is just draw yourself a rough sketch of kind of what's taking place here. So I'll have a board here, and a board here. We'll draw like a rough little bullet. Just make it like a block here. And move this into this place right here. Clone it, move it on to the other side. Okay. Alright, so now the first thing is the bullet is 1.68. So we know from here to here, we'll do that in meters, it's going to be 0.0168 meters. We know the distance between the board itself is going to be 0.108 meters. Okay, it says what's the average acceleration? Okay, so we're entering at 430 meters a second. So we'll draw a vector to represent that velocity right there. And we're coming out at this point traveling, I'll move it over here, we're traveling right here at 286. And 430 meters a second. Okay, again, I like to write what I know and what I do not know. I think it's a good way to set up these problems. We'll write down what we know and what we don't know. Okay, in this problem I know VI, my initial velocity, is going to equal to 430 meters per second. We know V final initially is going to be equal to 286, and when I mean by initially, because we're not considering the last part of this problem, 286 meters per second. Now we're going to be traveling, we'll call this our displacement, we're going to be traveling just the thickness of the board, because the bullet's going to enter and then when it just goes to exit, the tip of it's going to make the hole. And this is a little misleading, but because you would have some friction as the bullet travels out through that hole, because the edges would be rubbing on the bullet, but we're going to ignore that for right now. So that's going to equal to meters here. And what I do not know acceleration, and I do not know that delta t. We do not know those. I'll make this in vector 2. All right, so we'll write down our equations that we know, and we'll say that delta x, and I'll draw this as vector, is equal to vi times t plus 1/2 times acceleration times t squared. We know that vf is equal to vi plus my acceleration times t. We also know that Vf squared is equal to Vi squared plus 2 times my acceleration times delta x. And I'll leave these off because I'm squaring these anyway. Write down what you know and what you do not know. We know, again, we know Vi, we know displacement, we do not know acceleration, we do not know time. Here we know Vf, we know Vi, we do not know A, we do not know T. Here we know Vf, we know Vi, we know delta x, we only know t. I have 2 unknowns here, 2 unknowns here, and 1 here. So that means immediately I'm going to go to this equation here. I'm going to put in the information. My V final would be 286. We're going to square that. Is equal to my initial, which is going to be 430. We're going to square that, plus 2. Times my acceleration times 0.108. Move this to the other side, that's going to give me 286 squared minus 430 squared. We're going to divide by, in parentheses, 2 times 0.108, and that's going to equal to my acceleration, my average acceleration here. All right, we'll run those values real quick. That gives me 286 squared minus 430 squared, divide by, in parentheses, 2 times 0.108, close parentheses, and that gives me a really big number of 477,333.33 negative, and that's going to be in meters per second squared. All right, let's just go back, and I think I get the UT pulled up. Let's see if that's even close to what the right answer is going to be, and so I can find that real quick with the bullet problem. Acceleration 4.7333, and let's just see if that's what I got. Yeah, so that is the correct answer there. So that would be your acceleration right here. All right, so that's the answer to the first part. The second said, how long is a bullet in contact with the board? Now this problem's a little confusing. Basically, we want to find out what delta T is. Now if you think about it, let me go ahead and fill this in here and we can kind of talk about. Let's make this, we'll make the bullet red so you can see it. I'm going to take him out here. All right, as this bullet, it's going to touch the board here, it's going to travel across, it's going to touch the board here, but then as it exits, it's going to be going constant velocity because the hole has been made, and this bullet's going to be in contact during that amount of time. So you really have two. You have T1 and T2. T1 would represent the time from here to here of contact, and then T2 is the bullet goes through this last little bit through here where it's traveling at constant velocity. So we're going to work that problem. We'll get T1 while I'm in contact with the board while I have negative acceleration. To do that, we'll just go back to the equation. I'll do that in black. We'll go back to the equation that VF is equal to VI plus A times T. I'll put these as vectors real quick. All right, so now we know our acceleration, so we go back and we'll put VF as 286 is equal to 430 plus my acceleration, which is going to be negative 477,333.33 times T. We'll solve for T. It gives me 286 minus 430. We will divide by negative 477,333.33. I'll run that number right there. That gives me 286 minus 430. I will divide by that acceleration, and that's going to give me a time 3.01676 times 10 to the minus fourth. Okay, so let's go back to the picture and talk about what that time represents. That time represents the time the bullet's going to go from here to here. We still need to do the rest of this part. I'm going to be going constant velocity at 286. So can we not go back and say that the bullet is going to move its length of the bullet? So we can say that delta x is just going to be equal to VI times T, because I have no acceleration as that bullet goes out through that hole that's been made by the tip of it. So delta x in this case would be the length of the bullet, which is 0.0168. 0.168. My velocity is, I'm going to be traveling, it will be in this case 286. And we're going to solve for T. So T would equal to 0.0168 divided by 286. We'll do that real quick. 0.0168 divided by 286 gives me a time of 5.87413 times 10 to the minus fifth. All I have to do is add these two together and I will get the total time. So total time equals to, I'll grab those values there, plus, and I get the value of, really didn't change very much, 3.016 Make sure I got that right. 016. I'll do it one more time. I think I messed up here real quick. Do this one here, plus, grab that one. Okay, there we go. Do it again, write down that number. Sorry, I didn't get in my calculator right. That gives me a value of 3.604 times 10 to the minus 4 seconds. So that's the time. So you have to consider that last little bit of time that the bullet travels the rest of the way through the board. We'll go back to UT and just see if that time is right. And it is. So they got 3.6. Okay. So far, so good. All right, so let's go to the last question. The last question says, what is the minimum thickness of board would it be to stop the bullet, assuming the deceleration through the boards is the same? All right, so we want the deceleration to be the same. So we could go back, and we know what the acceleration is going to be. So now, if we wanted to stop it, we'll just basically go back to this equation here. We can go back to VF squared is equal to VI squared plus 2 times my acceleration times delta x. VF, we're going to stop the bullet. Our initial velocity when we entered that, again, was what? 430. We take 430, we will square that, plus 2 times the acceleration that we found up here, which is going to be minus 477,333.33 times delta x. We'll move this to the side. That gives me minus 430 squared. Divide by, in parentheses, 2 times negative 477, 333.33. That should give me my thickness of my boards. I will work that real quick. 430 squared. Divide by, in parentheses, 2 times 477,333.333 gives me a value of 0.19368 meters. We'll go back to UT and see if that number is pretty close to being correct and exactly dead on. All right. Hope this video was useful. This is the bullet problem on the University of Texas.